Hello and welcome to Train Signal. You're watching super high availability with VMware fault tolerance. In this lesson, I'll start off with an introduction to VMware fault tolerance, or FT. From there, I'll cover the requirements and constraints related to using it before we test to see if you can use fault tolerance with VMware Site Survey. From there, I'll show you how to enable fault tolerance on a virtual machine, and then we'll test failover of a particular virtual machine with fault tolerance to ensure that it really works and so that you can see it in action. With that, let's get started. VMware's fault tolerance feature, or FT, provides continuous availability for a virtual machine. That means that if a virtual machine is running on a physical server and that physical server is completely lost, let's say the power just dies suddenly, if it was protected by fault tolerance, it will have a shadow virtual machine running on another ESXi server, and that virtual machine will have zero downtime. So you may be familiar with VMHA, or VMware's High Availability, which provides a similar function. However, with VMHA, the virtual machines actually have to be restarted or rebooted, whereas with VMware Fault Tolerance, the virtual machines are always running no matter what. If a physical server is completely lost, the virtual machines just keep on running. So it takes VMHA to the next level. However, it doesn't work really en masse for like every virtual machine in a cluster like VMHA does. So VMware Fault Tolerance is for very specific virtual machines, those Tier 1 applications that require that level of continuous availability. The cool thing is that unlike other continuous availability applications or high availability solutions, VMware's fault tolerance works for just about every application out there and 99% of all guest operating systems. And that's because it's not doing some sort of a high availability within the operating system. It's doing a complete mirror or a live shadow copy of the virtual machine, everything in RAM, and all those changes that go through the CPU. So this is called keeping the virtual machines in lockstep. So VMware's fault tolerance actually uses what VMware calls vLockstep, an underlying technology similar to VMware Workstation's record and replay that actually monitors all the changes that go through a virtual machine's memory and CPU and replicates those changes on the other host. Again, the virtual disk or the virtual storage for that virtual machine stays in one place. It never changes because it's on a shared storage that both ESXi servers have access to. With VMware Fault Tolerance, the primary virtual machine is called, you guessed it, the primary, and the copied or lockstep virtual machine is called the secondary. So again, the virtual machines stay in the same place on the same shared storage and never move. So this is really like continuous vMotion. You likely watched the lesson in this course on vMotion that shows how a virtual machine that's 100% up and running, being used by end users, can move dynamically from one ESXi host to another ESXi host with no downtime, and that's because the shared disk stays in the same place and the CPU and memory changes are just moved from one host to another. So with VMware Fault Tolerance, it's like vMotion, but it's constantly happening, it's never ending, and it's just there in the event that one of the ESXi servers fails and the other ESXi server can take over. Because of how VMware vSphere's fault tolerance actually works by mirroring the CPU and memory changes from one physical server to another, it has some very specific requirements. So the CPUs on all fault-tolerant ESXi servers must match and must be from a specific list of processors. And there's a VMware knowledge base article that covers this. It's knowledge base article 1008027, and it's called Processor and Guest Operating Systems that Support VMware Fault Tolerance. So this is not just for the CPUs on the physical servers, it also discusses the guest operating systems, which I haven't got to yet. But if you scroll down here, it gives you the specific manufacturers and models of the CPUs that need to be in your physical servers, and then they need to be identical from the primary to the secondary server. It also discusses the guest operating systems, and how with specific guest operating systems, the operating system or the virtual machine actually has to be powered off before fault tolerance is enabled. It's that case if you're using, let's say, an Intel Xeon i7 or an AMD third generation Opteron. For example, with Windows 7, you can see here how it says yes off, yes off. So if you have those CPUs in your physical servers and you're trying to use fault tolerance, you have to power off the virtual machine, enable fault tolerance, and then power on the virtual machine. However, if you have a Xeon processor based on the 45 nanometer Core 2 microarchitecture, which it tells you more about up top here, these specific processors from the Intel Xeon series, the 3100 to the 7400 series processors, you can actually just enable fault tolerance on a running Windows 7 and a Windows Server 2008 virtual machine. So this is a document I highly recommend that you check out because it gives you so many specific details about CPU compatibility with fault tolerance and guest operating system compatibility with fault tolerance. I'm also going to talk in just a second about the VMware Site Survey utility, which it references here in the knowledge base article as well. Coming back to our requirements here, of course, hardware virtualization needs to be enabled in the BIOS of the physical servers, and really you need to do that even if you're just running vSphere. Fault tolerance has a recommended minimum number of 1 gigabyte NICs on each server, and that is 3. So 1 just for the standard VM kernel interface, 1 for vMotion, and 1 for fault-tolerant logging. And, oh, by the way, 1 NIC on each server must be enabled for fault-tolerant logging and vMotion. Of course, they recommend you separate that out. ESXi servers must be running the same build. Virtual machines must be on the same SAN, accessible by the servers, of course. And then fault tolerance needs to be enabled on virtual machines that are part of an HA cluster. Then finally, you need either vSphere Enterprise or Enterprise Plus. With vSphere 5 Advanced is no longer available, so you would use either Enterprise or Enterprise Plus. But what about constraints? Well, besides requirements, there's also a list of constraints. And in fact, if you go to the vSphere 5 Availability Guide, you'll find a huge section on fault tolerance and many pages that cover requirements and many pages that cover constraints. It can get really daunting reading all these. So I tried to quickly summarize them for you so you don't have to go through all that. The constraints are, with fault tolerance, it only supports a single vCPU in each virtual machine. In other words, no symmetric multiprocessing of your vCPUs is allowed on virtual machines being enabled for fault tolerance. Of course, fault tolerance requires a specific version of the virtual hardware, and there's a recommended minimum of no more than 4 virtual machines running fault tolerance on each ESXi server. And because fault tolerance is sending those changes to the CPU and memory across the network, they recommend that you have a line of sight between the ESXi servers due to latency. In other words, you wouldn't want to run fault tolerance between 2 virtual machines that were in different physical data centers, so let's say connected by a wide area network. It just doesn't work that way. It's not that sort of feature. If you want to do something like that, then look at VMware Site Recovery Manager, and they even have something called VMware HA Stretched Clusters, which is a very high-end feature similar to fault tolerance, but HA Stretched Clusters is going to require, even more, and Scott Lowe has some great presentations on that. Coming back to the constraints here, only thick virtual disks are supported with fault tolerance. You have to be using thick disks. Snapshots are not allowed on the virtual machines that have fault tolerance enables, and that includes backup products that use the vSphere Storage API for data protection, which would use snapshots to actually do their backup. So that's something you need to take into account. You don't want to just go around enabling fault tolerance haphazardly because you might not get backups of those virtual machines. You need to take these things into account. You cannot invoke storage vMotion on a virtual machine that has fault tolerance enabled, and link clones are not allowed on virtual machines with fault tolerance enabled as well. And then some guests are not supported and some guests require shutdown to enabled, and that's what I showed you over in the VMware Knowledge Base article. It specifically lists which guests are supported with fault tolerance, and depending on your processor, which ones will require that you shut down the guest, enable fault tolerance, and then restart the guest. Now, the best way to see if fault tolerance is going to be compatible with your physical servers and see if you've met all the requirements is to use a tool called VMware Site Survey. It's a free tool, and I'm going to show you how to use it in just a second. Basically, you point Site Survey to your HA-enabled cluster in the virtual infrastructure, and it'll tell you whether or not you can use Site Survey, and if not, what's broken or what's missing and needs to be fixed. You can also check out Eric Sloof's Fault Tolerance Checklist. It's a really nice checklist that walks you through all the different things that need to be enabled for fault tolerance. So first let me show you Eric's checklist, and then I'll show you where to download Site Survey and then what it can do for you. This is Eric Sloof's Fault Tolerance Checklist, and you can find it over at his blog, which is ntpro.nl. And I just went to the home page there, and underneath the quick search, I typed in FT Checklist. So this is just a nice checklist, I thought, that gives you all the requirements and the optional things related to configuring and enabling fault tolerance. Another tool I want to show you is the VMware Site Survey utility. And back here on this knowledge base article that we were looking at, there's actually a link here to download VMware Site Survey. It's at vmware.com/download/shared_utilities.html. And really, you can just Google for VMware Site Survey, and it'll take you to this web page here, the VMware Shared Utilities web page. And there's really just two utilities here. There's Site Survey, and then there's the CPU Identification utility. That utility is for checking on CPU features to see if your CPUs are compatible with vMotion and enhanced vMotion compatibility. Site Survey is more for fault tolerance configuration verification, or hardware compatibility and software compatibility related to fault tolerance. And it's not just a Windows install, it's actually a Windows install that installs a VMware vSphere client plugin. It's just a tiny little utility, just 6 megabytes, so the installation just takes a second. Of course, you have to have the vSphere client already installed, and then if you had the vSphere client running, you'd have to close the vSphere client and then reopen it to get it to recognize the plugin. So I already did the quick install, I already closed my vSphere client, I've already opened it, and now let's go over there and I'll show you what VMware Site Survey can do in relation to fault tolerance. So here in the vSphere client with Site Survey installed, if you go to your HA-DRS cluster, you have to go to an HA-enabled cluster, and then on that cluster, you look at the tabs across the top here. If you scroll all the way to the right, you'll see Site Survey. It's not maybe the last tab. In my case, it's the second to the last tab. And here's the Site Survey tab. And so far it says Site Survey has not been run for this view. So what I'm going to do here is to click Run Site Survey. And it says, do you want to run it for this view or all views? I'm going to go ahead and just run it for this view only and click Run. And here's what we get. We get a VMware Site Survey report. And if we scroll down here, it says it found my 2 ESXi servers, tells me when it was generated. It's a report for this cluster. And let's see, we've got 2 hosts here. We can expand things out and see what it tells us. The first host, ESXi server number 1, says it has a fault-tolerant version, BIOS is compatible, compatible CPU stepping, NIC is 1 gigabit or faster, ESX is licensed for fault tolerance, we have a compatible ESX version, but we have 2 problems here with the X's. You can see the vMotion NIC is not enabled and logging NIC is not enabled. The host does have shared storage. We can click Show Shared Storage here and see what shared storage it has access to. So 2 problems on the first host. If we scroll down, the second host has just 1 problem, and that is the logging NIC is not enabled. So this is what Site Survey is going to tell us. Basically what we need to fix on our servers to make them compatible with fault tolerance. It's a very cool, very useful free tool that installs in just a couple minutes and helps tremendously with the proper configuration of Site Survey. So before we try to go and enable Site Survey, we better fix these problems with our servers, or else it's just not going to work. So first let's go to ESX server number 1 here, and then we'll go into the configuration tab, then into networking, because both of our problems were related to networking. I'll go into properties here on the standard vSwitch, and I'll go to the management network. And notice here our VM kernel interface, it says fault tolerant logging is disabled and vMotion is also disabled. Now, best practices, of course, dictate that you should have separate physical network adapters, one for vMotion and one for fault tolerance. You should really break that out. But in this small lab environment, just to demonstrate fault tolerance, what I'm just going to do is go to Edit here, and then I'm going to check to enable vMotion and fault tolerant logging. In my case, I'll just say OK here. And really what it's doing now is giving me a warning about those best practices. It's saying, hey, you're putting all this on one physical adapter. Are you sure you want to do that? I'll just say yes for the purposes of demonstration. Close that out. And now we should be good to go for that physical server. Now let's go to ESXi server number 3. We'll go to Configuration and then to Networking and click on the Properties for the standard vSwitch. I'll go here to the Management Network Interface. You can see here vMotion is enabled, but fault tolerance is not enabled. I'll click on Edit. I'll enable fault tolerant logging. I'll say OK. Again, we get the same warning. I'll say yes and close. So now let's go back to the HA cluster. We'll go to the Site Survey tab. We'll go up to the top here. Let's click Run Site Survey. We'll rerun it and see if what we did actually resolved the problems. Okay, it looks like our report has been updated here. We'll scroll on down. We'll expand out the report for each of our ESXi servers. And it looks like we're getting check marks across the board here. There's no X's, so everything looks good according to Site Survey. Now that we resolved our configuration issues thanks to Site Survey, now which virtual machine will we enable for fault tolerance? Because we need to make sure that that virtual machine meets the requirements. You saw the operating system or the guest operating system constraints related to what type of processor you're running. Perhaps your virtual machine needs to be powered off before you enable fault tolerance. You also need to check your virtual machine to ensure that the virtual disk is using the thickly provisioned format, that you don't have any CD or DVD drives attached. There's a long list of things that you need to verify. You can find all those over in the vSphere 5 availability guide. Under the fault tolerance section, there's a list of virtual machine requirements related to fault tolerance. In our case, let's say that this Windows 2008 Active Directory virtual machine right here is the virtual machine we want to protect with continuous availability, with VMware's fault tolerance. We need to make sure that it meets all the requirements. I see it just has one CPU here. We need to make sure that it's not using thinly provisioned storage. We see the operating system is one that was supported by fault tolerance. Make sure it doesn't have any locally attached CD or DVD drives, and so forth. Assuming that's the virtual machine we want to protect, let's go back to our slides and quickly talk about enabling fault tolerance in vSphere. While the list of requirements and constraints for enabling fault tolerance may be lengthy, the actual process of enabling fault tolerance on a particular virtual machine is really super simple. All you do is right-click on a virtual machine, go to Fault Tolerance, and click on Turn on Fault Tolerance. From there, you'll see that the secondary virtual machine is created, and then you'll have a number of other options underneath that same fault tolerance menu. You'll also see a new section on the Summary tab of each of the primary and secondary virtual machines related to fault tolerance. So with that, let's go over to our vSphere client, and I'll show you fault tolerance in action. Here in my vSphere client, again, I've still got my HA cluster. Right now, DRS is disabled, but HA is enabled, and I've got my two ESXi servers and a handful of virtual machines. Really, I've just got two virtual machines that are actually powered on, with one of them being Windows 2008 Active Directory DNS. This is actually my Active Directory and DNS server for the WideBrain Coffee virtual infrastructure. And what I want to do is, let's pretend that this is a Tier 1 application, and I want to protect this virtual machine using fault tolerance. I want to use that continuous availability that it provides so that if either one of my ESXi servers were to go down, fault tolerance would protect the applications and the guest operating system inside that virtual machine. So to enable fault tolerance, let's just go to this virtual machine. We already checked it out to make sure we've met the requirements. You will have to remove CD/DVD drives that are connected to the client or remap those to host devices. You may also have to disable things like logging, symmetric multiprocessing, and hot add and hot plug of CPU and RAM. This virtual machine is all ready to go. So all we need to do is right-click on this and go down to fault tolerance. From here, at this point, the only option is to turn on fault tolerance. So I'm going to go ahead and click that. And this is the standard warning message we get every time we enable fault tolerance. It just says that the memory reservation of this virtual machine will be changed to the memory size of the virtual machine and maintained equal to it until fault tolerance is turned off. In other words, it's going to create a reservation for the virtual machine to ensure that that amount of RAM is always available to it, and so that that amount of RAM is never swapped out. It's always reserved and it's always active and available for this virtual machine. So I'm just going to click yes here. Let's go down and open up the task window and look at this. It says turn on fault tolerance, creating a secondary virtual machine. It's starting fault tolerance on the secondary virtual machine. Notice up here, this virtual machine has changed colors. Right now there's a little red warning by it. It says here that it's migrating the active state of the virtual machine. Notice this new box on the right-hand side here that says fault tolerance, and it says fault tolerance status is protected. The secondary location is ESX3. This virtual machine is actually running on ESX1. As you can see up here under the general section, On the fault tolerance section, it tells us the secondary location of the fault tolerant virtual machine. So the secondary virtual machine that it just created. Right now, the secondary virtual machine is not using any CPU or memory, or at least that hasn't updated yet. It tells us lockstep interval. It says not active and log bandwidth not active, likely because we just enabled it. But you can see down here that enabling it was successful, and we can tell that by the protected note right here in the status, and also by the color of the virtual machine over here. Now we're starting to get a little bit of information here with the lockstep interval and the log bandwidth. So if we scroll up here, again, this is running on primarily ESX1, but the secondary location is ESX3. If I click on ESX3, and on the Virtual Machines tab here, I have a virtual machine. Let's move this out a little bit, and we can see the name of it is the same name, Windows 2008 Active Directory DNS, and it's called Secondary. So it automatically created that virtual machine, and it put the word secondary by it, so we can tell that this is the secondary virtual machine. If I go to ESX1 and to the Virtual Machines tab, there's Windows 2008 Active Directory, and that's the primary, obviously, because it doesn't say secondary. Now, if we go and we right-click on the virtual machine and go down to fault tolerance, notice here we have some new options. So we could turn off fault tolerance, we could disable fault tolerance temporarily, we could migrate the secondary virtual machine to another ESXi server, we could test failover, or we could test restart of the secondary. So these are some pretty cool options we have here related to fault tolerance. If we just want to test failover, we could see what happens. But what I want to do is really do my own test. So I'm going to click on the virtual machine. The VMware tools aren't loaded on this virtual machine. I just haven't had time to load them, but I do need to load those up. But what I want to do is I want to right-click on this virtual machine, and I'm going to go to the console, and I want to show you the IP address of the virtual machine. Then on the console, I'm going to go down to Start, and let's open up the command prompt, and I'm just going to type ipconfig. Okay, so you can see here the IP address of this virtual machine is 10.0.1.20. So in my test, what I'm going to do is open up a ping window or a command prompt from my local computer and then just start doing a continuous ping to this virtual machine's IP address. And then what I'm going to do is to go in, pull the plug actually where the primary virtual machine is running. I'm going to pull the plug on that ESXi server, and then we're going to see if our pings continue. So let me go back to my local computer here. And then I'll just open up a command prompt. And then I'll just do a ping -t 10.0.1.20. Okay, now we're actually pinging that server. And then let's look back here. Let me double check before I pull any plugs. So the primary virtual machine is on ESXi server number 1. The secondary is ESXi server number 3. Okay, so we got our continuous ping right there. Hold on just a second. I'll be right back. I'm going to go pull the plug on ESXi number 1. Okay, I'm back. I just pulled out the power cable, and look what happened. We had one missed ping, but other than that, the ping times have been awesome, under 1 millisecond. The pings continue here. If we look back in our vSphere client, we can see there's a warning next to ESXi number 1. And now it says the host we're running on is ESXi number 3. So notice how those swapped. And down here underneath fault tolerance, it says we're not protected. We need a secondary virtual machine. We don't have another host to put it on right now. And there's a red warning over here, or an alert, next to that virtual machine because it's not protected. But the most important thing is that our pings never ceased. We just had one tiny missed ping there worth about 1 millisecond, something that an end user would never notice the difference. And that Tier 1 application is just going to keep on purring along with no problems whatsoever, thanks to continuous availability brought to us by VMware's fault tolerance. All right, so that's fault tolerance. If we wanted to get fault tolerance up and running again, I could just plug in that ESXi server. And then because fault tolerance is enabled, the secondary virtual machine would be automatically created back on that ESXi server once it's brought back in to the HA cluster. So with that, let's go back to our slides. And that brings us to the summary for this lesson. We started off by giving you an introduction to what VMware fault tolerance is. It's like VMware High Availability, but at a much higher level. It's extreme availability, or VMware calls it continuous availability. because even though a physical ESXi server may fail, that virtual machine protected by fault tolerance is just going to keep on running, and the end users are never going to know the difference. The cool thing about VMware fault tolerance is it works with just about any operating system and just about any application. But because of how it works, it has some very specific requirements, mainly revolving around your CPUs, and it also has some very specific constraints. Things like you can have no more than one vCPU, you can't have any connected CD/DVD drives or client devices, you can't be running logging on the virtual machine. Of course, the virtual machine has to be stored on shared storage. Snapshots of virtual machines aren't allowed, and you can't do a storage vMotion on a virtual machine once fault tolerance is enabled. I showed you how to test and see if fault tolerance is going to work with your infrastructure using the free VMware vSphere client plugin, VMware Site Survey. It's super small and easy to install, and then it creates a nice tab on your HA cluster, and then you can run Site Survey and see if there's anything that needs to be done in your infrastructure to make sure that fault tolerance is going to work. You saw how it helped us, telling us which ESXi servers needed the vMotion interface enabled and the VMware fault tolerance logging interface enabled. From there, I showed you how to enable fault tolerance on a virtual machine, and then we tested failover with a virtual machine using fault tolerance by pinging that virtual machine continuously and then pulling the plug on the physical server where the primary copy of the virtual machine was running, and there was no hiccups in the virtual machine or its applications, except perhaps maybe a 1 millisecond loss in ping connectivity. So fault tolerance is an awesome feature of VMware vSphere Enterprise and Enterprise Plus that provides continuous and extreme availability to the Tier 1 applications that need it most. Thanks for watching this lesson covering VMware fault tolerance.